Well, I guess we'll get started then. Guys ready to go?
Let's go.
Let's do it.
Well, thank you for attending. As you can tell, our subject today is reducing risk from your life safety and construction defects. So we are going to talk a little bit today about common construction defects in school developments, as well as some of the legal options that you have associated with if you find these problems. So we have a great panel today. Robert Jacobson's here from Levine, and he just finished what, two schools, three schools, two buildings, right?
Yeah, two schools in the last 3 years.
Perfect. So it's going to be real relevant. My name's Richie Lipson. I'm a lawyer with Kasdan Lipsmith Turner, and we represent school districts throughout the Western United States and in Hawaii. And we also have Gene Buick today, Chief Operating Officer of Elena Buick and Beers, one of the premier expert firms. And you have offices now all over now, Gene, right?
Yeah, we do. We're nationwide.
Nationwide. So Gene's got a very impressive background, and there's a little bit about him. 25 years. You're not that old, are you, Gene?
Yeah, it's been 25 years. I can't believe it.
Yeah, I think I'm coming up on 22 doing this kind of practice of law. So how about you, Robert?
I'm actually 16 years in school business, but 30 plus years in construction.
All right, so you got close to 100 years here on the panel, so that sounds good. Makes us sound ancient.
I just feel older now, Richie.
Yeah, right. Gene, you want to tell a little bit about?
Yeah, a little bit about our firm, and thank you for those that are attending. Elena Buick and Beers, we're an architectural engineering firm that specializes really in the building envelope enclosure, mechanical systems, energy conservation. And we worked on thousands of projects over the last 30 years. Kareem Alana is our founding father, and once upon a time started off as a roof consultant. And as a roof consultant, you learn that there's more than a roof, and windows can be a problem. Below grade issues can arise. You have condensation problems. So we've grown over the years to be a full service firm. One of the reasons why we're pretty well known for our experience and knowledge is that we've studied a lot of failures. So fortunately or unfortunately, we do get hired to understand why buildings fail, and we get an opportunity to see what works and doesn't work. And we enjoy sharing these stories to hopefully help our clients avoid problems in the future. But we don't just criticize how buildings fail. We also walk the walk and talk the talk. So we design, we construction manage and inspect construction, both remediation and new construction, to help ensure that the buildings perform as they are intended and designed to be. We work with many clients, public, private, and we work with a lot of community college districts around the country. Oops.
Was that you clicking or me?
Yeah, I just.
Okay,
so
perfect.
There you go, Richie.
Perfect. So today, I think our goal is to cover just to make sure that you walk away with identifying common issues in new construction. Like Gene said, we've got some real life examples that we're going to share with you. And then just another kind of take on how you can look at and do these inspections yourself, what to look for, and the best practices of how to do it yourself inspection. Then we're going to talk a little bit about the statutorily required inspections in Arizona, and then also talk about the timeframes, statute of limitations, and statute of repose, the absolute cutoffs you have to bring claims if you find construction defects that develop, how to best approach developers or builders to resolve problems, and when is the best time in this cycle to involve someone like Gene or someone like our firm. So that's what we'll cover today. And Obviously it's taxpayers' money, and if these defects aren't addressed within the timeframes that you need to bring a claim, then you have a real potential of getting stuck with ongoing maintenance costs that you shouldn't have, and really make the project not as successful as it should have been. We'll talk a little bit about the 1-year express warranty that most contractors give, sometimes 2 years in their contract. And we'll also talk about the fact that in Arizona, you have up to 8 years to bring a claim for specific construction issues. We'll talk a little bit about that. And we'll also talk about the fact, that most of these projects are covered by insurance and performance bonds, and what that covers and how you can bring claims to trigger that coverage. Because a lot of these guys have already taken their profit off the project, and if you're coming back 2 or 3 or 5 years later, where does the money come to fund these repairs? And often comes from insurance products. So I'll turn it over to Gene. And
thanks, Richie. So the slides that I'm about to present I'm going to talk about 2 case studies where there were forensic failures subsequent to the original construction, and we'll talk about some of the common issues we find. In terms of common defects in new construction, why is it that this happens? And more often than not, it's really a quality issue or a workmanship issue. Once in a while, design comes into play as well, but the quality construction can be, and especially poor quality, can be a major liability. You do have insurance. It can alleviate most costs, but it is a very costly process to go through, and it's quite intrusive. We've had, unfortunately, some projects where the owners were too late, so to speak, and unfortunately they had to pay out of their own coffers, they had to pay for the repairs because the claims weren't made in a timely fashion. So if you miss that statute, it could be very, very expensive. In terms of issues in new construction, certainly with windows, when they leak, there's reasons for that: improper installation. We've seen fogging glass issues, noise, actually problems with coating and finishes on the windows themselves, particularly in marine environments. Or abrasive environments that can cause coatings to peel, and there's other glazing issues. Air conditioning systems not performing properly, either they're undersized or they're not connected properly, they're not balanced properly. A lot of issues with that. Roofing and waterproofing, very common and very expensive to repair. Just on a little bullet point for you on waterproofing, although the waterproofing may only cost $15 a square foot to repair, to install originally during new construction, but to repair it can cost well over $100, $150 a square foot. So it can be a very expensive process. In terms of stucco, lots of issues with stucco: cracking, improper installation of the lath, issues with the substrate, all of which contribute to potentially leak issues and damage to the substrate. There's also, of course, we see at times fire suppression issues. And then plumbing problems, something as simple as hot water not being delivered properly to the sinks. It can be a major issue. Our first case study, we'll talk about a college, a brand new library. You can see there's stucco and metal framing and sunshades and screening. This particular college was actually located up high on a hill, and a very windy, rainy environment, foggy as well. So this building's really subjected to some harsh environments, and so the building really needs to perform and needs to be constructed correctly so it could withstand a harsher environment. We have one defect in our slide. It actually was completed around 2013, 2014, not 2017. Of course, public funding helped pay for this project. It was a design build. Unfortunately, the cost of repair ended up being over $12 million. And in this particular instance, our client did file a claim in a timely fashion and was able to recover. Again, the building's 3 stories on grade, slightly on a hill. There's a low slope roofing, HVAC equipment. The cladding consisted of stucco, There was also some ornamental tile work at the entry of the building, and then we had curtain walls and storefront window assemblies. There's also actually a split slab waterproofing system, so some courtyards on the building that had topping slabs protecting waterproofing that also leaked. And sometime in 2000 and let's say 15, we were actually called out because of some window leaks. So here you have a brand new building, and the college called us up approximately about a year and a half after the construction was completed to report some leakage, and they were trying to understand what was going on. And you know, they did reach out to the contractor, but wasn't getting much of a response, and realized soon thereafter, after contacting us, that a deeper study and investigation needed to be performed. So this is the inside of a library, and there were some office spaces, and they had some pretty severe leakage. Leakage that resulted in peeling paint, damage to the drywall, and wet carpeting. A major inconvenience to the students and the staff. As part of our investigation process, we'll pull out and try and understand where these leaks are. And oftentimes leaks aren't visible, and you have to peel the onion, so to speak, to see where they're occurring, but other times they're obvious. And so what we were able to do in this particular case during a rainstorm is actually annotate floor plans to indicate where we saw the leakage. And you know, the staff was instrumental too. They were really, you know, maintenance staff was familiar with the building. They also understood where the issues were, and they did a really good job in helping us along to help study this issue. Here's a photo of a window, and this is just a simple rainstorm. A little bit of wind, and water came right through the window assembly, right into the interior, so it's an obvious leak. We do have tools and a variety of equipment that we use when we investigate to help really show, you know, the concern. And so what we have here is an infrared camera, and we took snapshots with the infrared camera to show the extent of water intrusion. And if you look to the left, you could see the blue outline, and that blue is a waterlogged, soaked carpet. And you could see that there's just a ton of water coming into the interior. And it's intruding upon the tables where the students are trying to study. Another little tool or trick that we use to help show the water is using litmus paper. We all used that once upon a time in our chemistry class, and it changes color. And so when it gets wet, it turns a violet or a purple color. Of course, the maintenance staff had to take out their caution signs to point out that there's wet flooring and stay away from it. But you can see how wet the floor got. Other defects that occurred as a result was damage to the paint and the drywall finishes. You could see the ceiling tiles, they were getting water stained. And this is a brand new building, you know, very, very young, already experiencing such severe problems. To help prove our case and to help the client during the litigation process, part of our protocol is actually to develop testing procedures and use equipment such as, in this case, we have a Retrotec negative air chamber and windblower system where we actually replicate negative pressure on the window system to do two things. One, to understand if the window assembly as installed was performing as designed and specified. And then two, we also wanted to replicate reported leakage. And we've done both static test and then negative chamber testing. So with and without negative air chamber testing, and we got leaks in both instances. You could see here in the photos, we replicated leakage. You could see water streaming through the window, through the glazing pockets, through the framing members. And of course, and I won't recite every bit of data, but we did create some exhaustive testing tables to help show the other side, the defense experts, what the results were when we tested it. Was it a window issue? Was there historical staining, whatnot? And what the results of the testing were. In addition to the spray testing, we oftentimes complement the spray testing with some destructive testing. So basically what we do, like doctors, we perform biopsies on a building. And the purpose of that is to understand what the underlying condition of the building components are. You know, how bad is the damage? What can we expect? Are there other potential problems underneath that we might miss otherwise without performing it? So in this case, and I'd previously shown you there was large steel structures penetrating the building, we had these large beams that were supporting the shading system, the shading structure, and these beam penetrations weren't properly flashed. And the building, you know, being only a couple years old, already experienced rust on the flashing. So we have this weather-resistant barrier that's supposed to shed the water. Well, water got through it, through the flashing deficiencies, got behind it, and rusted out the flashing, and ultimately did damage the substrate. And the lath on top of that was really subjected to an excessive amount of moisture intrusion. There was a lot of cracks, and water got into the stucco and caused premature corrosion of the lath. Another defect that we saw, or damage that we saw, was when water did get through the stucco, it caused the sheathing to become fully saturated and rusted the framing, and also the sheathing excuse me, was very soft and crumbly and needed to be replaced. One of the side effects of having leakage, unfortunately, is mold. And due to the leakage, there was mold on the sheathing that needed to be abated and removed. Special chambers were constructed on the interior to protect the students and the staff while we opened these things up during the course of our testing. Here's another example of some mold, again, all of which needed to be abated during the repair process. Another defect that we found during the course of our investigation, in addition to the leaky windows and the stucco penetration issues, was that the sunshade itself was improperly coated. The coating was too thin and it was rusting. And so that needed to be addressed as well. And we performed thickness readings on the metal and identified that as an additional defect that no one really knew about until we got the scaffold up and looked at it closely. So during the course of this process, we have to prepare what's called the defect report. And the defect report lists the defects, describes the deficiencies, and there's actually some additional information that further explains the defect in the terms of code, non-compliant code work. You know, it describes the deficiencies in terms of having deviated from the construction drawings. And then also within the defect report, we describe generally how we feel the building needs to be repaired. So a lot of defects, improper sealant joints, self-adhered membranes being improperly installed, so on and so forth. Window issues. When we studied the windows, there was just sort of a confluence of deficiencies. Horizontal members not being sealed, which resulted in leaks. Gaskets being undersized or unsealed at corners. The brake metal at the window jambs, so the sheet metal that integrates to the window was improperly sealed, in fact, improperly soldered. The windows weren't straight, so they were out of plumb. There was clogged weep holes. Anti-walk blocks. At one time, you could actually insert a ruler through the glass and into the exterior. So the glass moves thermally, and without these anti-walk blocks, they move excessively. And so that's another deficiency that needed to be corrected. In terms of the repair, so during the course of litigation, clients have two choices: wait for the case to settle. Oftentimes they do have to wait because there's really no funding there to fund the repair. So you wait for the case to settle and they need to perform the repairs. Or in this case, our client was fortunate enough to have enough funding to actually move forward with the repairs. So while we were litigating the project with the attorneys, we also developed construction documents that went out to public bid to repair the building. And in our scope, based on our testing, we determined that 100% of the stucco needed to be replaced on the west elevation, south, and only in partial elevations at other locations. And that's because the workmanship varied. In some cases it was better, some cases was worse, but we were able, through our testing, help come up with a scope that was appropriate for the building. We also replaced designed replacements of window flashings and sealants and required other flashings to be repaired. So again, I won't recite everything that took place for the window walls, but nonetheless, as you can see by these bullet points, there's a lot that needed to be included for the repair of the window wall assemblies. And in our case, we were able to salvage the window wall system. Generally, it was in sound condition, but it needed to be rebuilt and reinstalled. So it got disassembled, it got resealed, there was repairs performed to the glass, we put in the anti-walk blocks, and the exterior and interior gaskets were repaired as well. The plaza deck assemblies were also problematic, and as I described, you know, the waterproofing only cost $10, $15 a square foot, but to repair it cost a lot of money, well over $100 a square foot. So the contractor had to remove and replace 100% of the topping slab. They had to break stucco to integrate the flashings, and we also had to replace expansion joints that were leaking into the interior as well. So again, we prepared full set of drawings, which the client funded out of their own coffers during the litigation. Went out back to bid to contractors that understood how to repair a building of this complexity. Bids came in over $12 million. And shortly after the project award and start of the construction, there was a settlement, and the client did settle with the contractor and got sufficient enough funding to help pay for the repairs. So going to our second case study, it's a performing arts center, beautiful building, stone cladding, over waterproofing. You can see these large structures, shading structures, and curtain wall assemblies. So from a distance, the building looked great when it was completed, but shortly thereafter, after a few rainstorms, there was a lot of leakage in the building. So building was completed around 2003. The cost of repair, though, was $24 million. So a lot of money spent to fix the issues on the building. So it's a 106,000 square foot facility, multi-level, an extensive curtain wall assembly, and we were hired to help investigate multiple leaks. So here's a snapshot of the east elevation. We have sunshades, curtain wall, and a balcony deck. Very, very complicated construction, and also stone veneer walls. So after the reports of leakage, we were hired, and we had to perform testing to try and figure out what the contributing sources were, and there were many contributing sources. So we actually took spray racks and spray tested the stone assembly, and we were able to recreate leaks. And as you can see on the interior, we had to have a contractor remove the drywall, and then we saw water entering into the cavity, and there was damage occurring. You could see just the streaking, so very, very extensive leakage, and for a building so young. The contributing sources, window flashings around the stone. The stone itself, water got through grout joints, and it penetrated through very thin waterproofing membrane. The waterproofing membrane was just almost paper thin. It had cracks and splits and voids, which unfortunately allowed water to enter through the stone and waterproofing barrier. Again, the side effects of water intrusion, unfortunately, are mold. And, you know, here again, we have students and staff, and this needed to be quickly remediated and repaired. So including the spray testing on the stone, we also destructively tested the stone around the windows to understand what the failure modes were. So these biopsies are critical to understanding the extent of damage, but also understanding how and why the building failed. And then it's instrumental in helping us develop repair solutions so that when they repair it, it's done properly and helps repair those deficiencies. You know, one surprise that we saw were a condition where water should have weeped out when it got to the stone out on top of the window, and it didn't. And it was because the weep holes were blocked. And the sealant didn't have weep holes, and so there was a failure to recognize that if incidental water traveled through the stone, it needed to get out, and it couldn't. And on this lower right-hand photo, when the water did build up, it rusted the framing out. It couldn't get out. It couldn't weep out. So all of that needed to be repaired. Again, curtain wall leaks through the flashings and through the curtain wall itself. Water testing replicated leaks, and you could see just how severe the leakage was. Water's just pooling on top and then flowing onto the flooring. One of the things we do look for is signs of historical leakage, and as the left photo is depicting, as you could see an outline of pre-existing staining, you could see how severe the leakage can get during certain rainstorms. Water flows from the curtain wall all the way through the hallway. And when we tested, you could see that how the water started to flow again and repeating the same pattern of leakage. Another issue, shrinkage cracks in the slab. There was a problem with the curtain wall assembly down at the ground level, issues with flashings, and water just got through the ground level. So one thing I wanted to point out, the severity of leakage. We sampled and documented 167 leaks. That's a lot. And we had to catalog them, indicate where they occurred, and eventually the case settled. We had to perform exhaustive leak maps on the roof plans as well. So it wasn't just the curtain wall, it wasn't just the stone, it was also the roof systems. We also prepared maps of where several of the curtain wall and wall leaks were occurring as well. So all of this documentation helped prove our case and helped inform the defense as to how extensive these leaks were, and it was really important to work something out. So what was the resolution? Again, the university pursued claims against the bonding company, and we did prepare construction documents for the repair. And interestingly enough, in this case, the bonding company agreed to fund the repairs. And although this is probably more of a rare occurrence, but it does happen, the original general contractor agreed to fix the issues. And so through mediation process, there was an agreed upon repair scope, and the building is now repaired. So I've just gone through these two case studies. What I'm going to do right now is talk about the importance of being aware of your buildings, the importance of doing your own inspections. And with maintenance staff and facilities, you're always stretched thin, and it's sometimes difficult to keep tabs and track on issues. But when you do find an issue, there are methods of recording this information that are really helpful to the experts and the attorneys. So let's talk about do-it-yourself inspections. Well, one, I'm preaching to the choir, but it's critical to regularly inspect your newly constructed buildings. Just because you have a brand new building doesn't mean there aren't problems. And so it's really critical, particularly with these statutes, that you do regular inspection and look for signs, cracking, leak issues. And you really do need to document it thoroughly, both on a micro and macro level. We'll talk about that, meaning up close and away. Help understand, what you might feel the extent of the issues are. But we got to accurately document it and date stamp it. Those dates are really important. And something that people overlook at times, save those receipts. In many instances, you can't afford to wait. You have to hire a waterproofer or a caulker to do an emergency repair. But record those costs, because oftentimes those are recoverable. So again, photo documentation. In today's technology, we have our iPads and tablets and phones, and so we have a lot of opportunity to take photos and record that, and then catalog it and store it somewhere where it's accessible. So the important thing is, if let's say you have a window issue, take a big picture overview shot of the window, try and identify the areas on plans. And I've shown you examples of how we've shown leaks on plans through the use of annotation, putting in little blue dots or red dots. Take up close-up shots, identify the area location by taking photos of the room numbers or plaques, just to give some context for where the issues are. And again, take zoomed out photos and take zoomed in. And I can't tell you how many times we'll get a great shot of a photo up close, but we really don't have a good idea of where it's occurring. So take a deep breath, take a picture of where it's occurring, take a picture of the room number or unit number, zoom in and zoom out. So big picture, an overview shot. If by some chance you do have a Google shot, a Google aerial photo, take those. These are really helpful. I mean, as much as plans are helpful, the aerial photo off of Google Earth or similar software program is really helpful to us. Mark up a photo elevation or the elevation drawings themselves to indicate where these issues may be occurring. All of this plays into the big picture of being able to accurately document. Show the actual leak. It's helpful. You know, I have some clients that it actually will take videos. So you have real live drippage, use that video camera, because that video is really instrumental in showing what the severity of leakage are. You know, a photo, you know, speaks 1,000 words, but that video is worth, you know, tens of thousands of dollars. Again, here's a photo. Take a photo of the room number. Where did you see the leak? You know, there are industry guidelines that you can use to assess your building when you do this regular inspection, one of which is the ASTM 2018, a standard guide for property condition assessment. It's a pretty long document, but it gives you ideas of how to document, what to document. It describes what to review, you know, the structural framing and enclosure, the roofing, the plumbing. It gets into ADA things. And so, you know, there are experts out there that do this for, you know, acquisitions. You can also do it for existing structures. But it's a nice guideline to review and be aware of. You know, what's the difference between a property condition assessment and facility audit? You know, with PCAs, you do include identification of construction defects, and also provide, you know, repair tables with cost. You know, what's an immediate need that needs to be addressed? What should you be reserving? Facility audits also, though, include a good inventory and survey of the facility's equipment and assets. Gives a snapshot in time of how they're performing, how they look, and what their conditions are. So bottom line is it's important to have good record-keeping practices of your facility and how they're performing. And when an issue arises, you know, some thought does have to be put in as to how to address that issue. You know, I can't tell you countless times where an owner, over the course of 5 or 7, 8 years, goes back and forth with a contractor and attempts to get a resolution, and the contractor offers a sealant repair and whatnot, and it drags on. And sometimes that dragging on without the help of an attorney or an expert can sometimes result in missing a statute and missing an opportunity to get some funding or an agreed upon repair scope to repair your building. So with that said, Richie, I'm going to pass it on to you.
Hey, thanks, Gene. That was very informative. Our firm, like I said, has offices throughout Arizona, New Mexico, Hawaii, and California. And we not only do school districts, we represent municipalities, and then we represent large apartment developments as well as high-rise and condos for homeowner associations. There are a few statutes, and I know Robert and I have talked a little bit about this, that first of all, there is statutorily required in Arizona that a school district develops a routine preventative maintenance program for its facilities. And obviously, you know, if you're going to be developing a system, you're going to have to come up with some visual inspection program or regular facilities assessment program to be able to comply with that requirement. The most important protocol that has to be regularly checked is a roof inspection protocol, and that has to be coordinated before any repair or replacement of any roof elements are done. And this one's required to be done by a registered structural engineer or some other professional like Gene or other with training and certification, not a roofing subcontractor, the way I read the statute. And Robert, has that been your experience with these type of inspections?
Yes, you're correct.
Yeah, okay, good. Now, one thing that when we were preparing for this, we Robert and I chatted for a bit, that the school facilities board has a preventative maintenance guideline, and they are also required to go out and do random inspections. They're supposed to do 20 a year based on their statutory charter, but it looks like the last one they've done is 2017 or 18. So maybe they're just not funded enough to do those. But if you go to their website, they have a complete, very detailed preventative maintenance approval form that it requires and weights inspections to be done and weights each category. So 25% roofing, 25% electrical, for a total of 7 specific preventative maintenance categories. And that form is supposed to be completed annually and kept by the school district. So it's a very detailed inspection program. Again, we talked the difference between, Eugene mentioned, between a facilities audit and a property condition assessment, which is really 2 different animals. And of course, here's the statute that requires them to every 5 years randomly select 20 school districts for every 30 months and inspect them. So I want to talk a little bit about, with the few minutes we have left, just the time frames to bring claims, because most of the time what we see in these claims is an express contractual warranty. So sign a contract with the general contractor, and it in the contract will provide a specific type of warranty. And Robert, are you getting 1 year or 2 years specifically in those recent buildings you did?
2 years.
2 years. So you get 2 years in express warranty. So that's a contractual warranty that's provided via contract. In Arizona, you have 6 years from the breach of contract to bring claims for faulty construction. So if you have your express warranty, you can bring claims on, but then you also have a contractual warranty for the contract that's been done, and 6 years from date of when you knew or should have known. So that's the outside date to bring the claim for the breach. Now, there's an implied warranty in Arizona as well, and there's been a lot of litigation. It's been in the Supreme Court twice about whether or not the implied warranty of habitability and fitness extends to commercial projects or governmental projects. And that implied warranty extends the express warranty to 6 years. So it would provide you 6 years to bring a claim for construction defects, even if the express warranty was only 2 years or 1 year by contract. So the question's been answered by the Supreme Court is that the implied warranty does apply to commercial products and projects and governmental projects. So we know it applies. The thing that's been resolved recently is whether it can be waived or not. And most of the time, I'm sure you're going to see a waiver of the implied warranty. It's something to try to negotiate and get out, because you definitely have an implied warranty. If you can get it out of the contract, then it gives you an extra 6 years for construction defects. Now, the important thing to know is that the outside date or the deadline to bring any claims in Arizona for anything related to construction is 8 years. So that's, no matter what your contract says, no matter how long you've got from discovery, 8 years is going to be an absolute bar date from substantial completion. So when do you, approach contractors? How do you approach builders? I think Gene said, and geez, we just finished a $22 million settlement in Northern California, and they had gone on for 4.5 years back and forth about attempting repairs. Bond money had been involved in trying to make repairs. They really went down the path of trying to get things resolved, and it was well documented by the district. But sometimes we think it would have been a lot easier for us to be involved earlier. So at least when you're negotiating, it does make sense to bring in an expert early, just to see if you can have the scope of what the problem is. And in this case, they had made repairs that didn't work. So they spent 4 years making repairs. The repairs didn't work, and we found out the problem was project-wide. When do you bring in someone like us? I think it's always good to start with an expert. We like to bring in the expert because, the discovery is attorney-client privileged. But surely to figure out if you've got a case early on, especially before you're giving any kind of notice of any formal notice of a claim, it's always good to have your counsel involved. Construction defect litigation is a specialty. That's all we do, and it's very focused on on construction related claims. And I think we're about running out of time, so maybe go 1 minute over. If you think you have a defective construction, your clock's ticking. There's no question to know that, once you put on notice that there's issues, water intrusion, cracking in your concrete, stucco, clock is already ticking. The other side is going to argue that you're on notice that there's issues, especially if you're, a facilities or project manager. If you're getting close to 6 years or 7 years old, get it inspected. Have a really good look at it, because at 8 years you're going to lose your claims. Most attorneys that do work in this, at least our firm does, work on contingency. There's no upfront dollars for the district, and we advance all the costs. So any cost of recovery is pushed back on our firm, not on the district. So it's a good thing for the district as well as for the for the taxpayer. And just inspect your building regularly. Bring in outside experts to do it. Please, the more documentation you have, the better it is, and the easier it is for us to bring claim. Know the deadlines of the claim, and bring in experts as soon as you can. Robert, do you want to add anything before we ask him any question?
Yeah, I just want to piggyback on what you gentlemen have already kind of really said. Well, one thing too, if you're fortunate enough to build a new building, is as the building's getting constructed, walk that building. Try to go through every aspect of it. Get onto the schedule. Know when your electrical is done. Know when your AC is getting done. Know when your roofing is getting done, and walk those items. Because even if you're not an expert, there's some stuff that you can actually point out. You're not going to solve everything, but you might be able to find some stuff. In the last two buildings we built, my guys had walked, the AC guys and stuff, and we found some stuff that wasn't quite right, that you can get that before you really start down the closeout document trail. And then just kind of piggybacking off what Eugene said was walk for preventive maintenance, because realistically, those little leaks turn into major problems. And if you can get those early in that warranty period, it's well documented at that point. So that way it gives these guys a chance to really, if we have a problem, come back. And if we're documenting that and we're getting them when they're drips instead of when they're full gushers, it really will help out in the long run to save the building and extend that life. So that's what I would recommend to any district at that point.
Yeah, it's good.
Yep.
Well, we appreciate your time, and didn't appear like we got any questions. So thank you so much for joining. Thanks for the opportunity, Robert.
Thank you.
Thank you.